Hello everyone, welcome to Fukusaki Laboratory. In this video, we would like to explain about one of the research topics in the laboratory, namely food metabolomics. From raw materials into food on our plate, the food has been going through many processing steps. These processing steps, such as storage, cooking processes, can affect food components that reflect in their taste, or we call it sensory attributes, and affect the whole food quality. Food metabolomics in Fukusaki Laboratory focuses on analyzing small molecules such as amino acids, sugars, organic acids, and many more to understand about the food production and processes. Such analysis can give discriminative, predictive, and informative informations to both food industry and consumers. First, let's talk about predictive analysis. Metabolomics enable researchers to predict various food phenotypes through statistical model. This is done by utilizing metabolome data as explanatory variables and sensory analysis data from trained panelists as response variable. Another type of analysis called discriminative analysis focuses on investigation on the difference of a food sample within the same food type. While for informative analysis, metabolomics can characterize and identify target compound to search of novel bioactive compounds and create metabolic database of a specific food sample. Metabolomics approach can be applied to various food products. This includes natural products from agriculture and aquaculture to processed food products such as fermented food and chocolates. Application of metabolomics into these products can let us do component analysis, quality improvement, authenticity assessment, and also monitoring the diet. Now, let's talk about studies that had been already conducted in Fukusaki Laboratory. First is metabolomics for fruit ripening studies. For example, banana and mangosteen is a fruit that can ripen even after harvest, and the color changes are commonly used as ripening parameter. In our study, we use metabolomics analysis and color measurement as response variate to correlate the ripening process and metabolite changes. This study could provide important clues for understanding ripening mechanism and identify biomarker that might be useful for post-harvest technology. Besides fruit ripening, study of different cultivar or variety of fruits can also be performed with metabolomics. For example, in this lab, we also conducted component profiling of mango from different cultivar. We conducted metabolomics approach and sensory evaluation with the collaboration of Indonesia Research Agency to obtain characteristics of these mangoes. The data from this analysis can be used to perform discriminative analysis to identify unique attributes of these mangoes. Another study is metabolomics for tempeh. Tempeh is Indonesian fermented food that is made by inoculating fungi with soybean. The soybean will be engulfed with white mycelium, and this produces solid texture. Globally, tempeh is known as a meat substitute. In Fukusaki Laboratory, we study the differences of tempeh production method and analyze the differences of metabolome profile from each production method. Using metabolomics approach, we can discriminate tempeh based on their production procedures by using color data as the response variate due to the darker color from the traditional production. We also perform metabolomics to white leg shrimp and its sensory value. Current quality evaluation of shrimp in Japan is by using size. However, using size alone cannot determine the sensory quality. Therefore, metabolomics able to indicate the taste quality from its component. The result from this study is that shrimp size is not correlated to better sensory quality, but with metabolomics, we can predict umami, sweet and salt taste based on the metabolome data. One of the most interesting study is coffee metabolomics. This because many people love coffee. To determine coffee quality, there is a standard procedure called cupping test that is conducted by trained and certified people. If the coffee scored more than 80 out of 100, these coffee beans will be categorized as specialty coffee. In order to know what are the key compounds that correlated with this specialty coffee, metabolomics is a powerful tool to answer this issue. So, the cupping score and metabolome data were combined and correlated using multivariate data analysis. The result from this data analysis suggests compounds that has important correlation with coffee quality. To validate the result, validation by addition test is necessary to be conducted. Besides food, Fukusaki Laboratory also conducted analysis of food condiments such as soy sauce. Soy sauce is considered as major seasoning in Asia, and development of different soy sauce from various raw materials has been conducted. However, the effect of these different materials in soy sauce is still unclear. Using volatile or aroma component and hydrophilic component from GCMS and sensory evaluation, we can understand that soy sauce can be discriminated based on the three groups: grain, bean, and animal-based soy sauce. Different origin of soy sauce also could give different flavor attributes due to its relevance with the respective country. To study about what metabolites is important, sensory analysis and metabolomics can be conducted to identify highly correlated compound. We had also analyzed one of the most important drinks in Japan, that is Japanese green tea. Due to its popularity in Japan, we can rank the green tea by its sensory score obtained from trained panelists. This sensory score can be correlated with metabolomics obtained by using NMR, FTIR, LCMS, and GCMS to obtain important metabolites that determine the ranking of green tea. As a result, several high-ranked tea has epicatechin component as their characteristic metabolites. This slide shows the list of publications related to Japanese green tea researchers. Meanwhile, this is the list of publications related with soy sauce, foods, and coffee researchers. And this slide shows the publication related with fermented food, for example, cheese and tempeh. That's all for now. If you are interested or have some questions, you can contact us or come to Fukusaki Lab directly. Thank you for your kind attention, and we hope to see you in the future.